Hi there, I'm Tim Kenyon, an emergency number professional certified by Nina and Vice President of Product Management at Synergem Technologies. Along with my good friend and colleague, Elaine Cotu, Synergem's Director of Product Development, we've put together this quick overview to show you how the Synergem Emergency Services Routing Proxy, or ESRP, processes a 911 call event. We'll take you step by step through the call flow, highlight the key functions of the ESRP within the Nina i3 architecture, and show how Synergem's implementation ensures secure, reliable, and standards-based routing for every emergency call. We put this presentation together to give you a clear, easy to follow look at how a standard Nina i3 911 call flow moves through the Synergem session controller and the emergency services routing proxy. In this session, we'll start with a high-level overview of the ESRP and its key roles, location discovery, policy routing, and SIP session management with the SSC, as typically deployed in our production environments. Then, in later sessions, we'll take a deeper dive and break down each functional element one by one, following the definitions outlined in the Nina i3 standard. Before we dive too deep into the presentation, I thought it would be helpful to pause for a minute and go over a few key terms and definitions. As you know, our industry loves acronyms, and it's easy for us to slip into that alphabet soup and forget that not everyone new to NG 911 has all those terms memorized just yet. So first on the list is ASC, which stands for Application Session Controller. This was the predecessor to our Synergem Session Controller, or SSC, which you'll see mentioned a lot throughout this session. Also on our list today are the ESRP, the NGCS, which is the Next Generation Core Services, the PRF, or Policy Routing Function, and of course the ever-important PID-of-Flow. Take a little time to get familiar with these terms. They'll start to feel second nature as we continue through the material. So what is an ESRP? The Emergency Services Routing Proxy, or ESRP, is the heartbeat of any next-generation core services architecture. Defined in the Nina i3 standard, it handles policy-based SIP call routing within the Next-Gen 911 environment. Working alongside the Synergem Session Controller, or the SSC, the ESRP acts as an application layer SIP proxy. It receives emergency call signaling, applies policy rules from the PRF, and uses location data from the ECRF and LVF to decide where the call should go next. Is that another PSAP, another EZNet, or the destination PSAP? By replacing the old circuit-switched selective router, the ESRP enables location and policy-driven routing across modern IP-based emergency networks. In Synergem's implementation, the ESRP and SSC form the intelligent SIP-based routing core of the Synergem NG911 platform, delivering secure, deterministic, and fully auditable call routing in complete compliance with the Nina standard. Today's sample ESRP call flow begins when a SIP invite is received at the ingress SSC from the BCF, or Border Control Function. In this scenario, all calls are anchored at the media bridge, which acts as a conference-aware user agent to manage all session media. An optional third-party policy store is also shown in this example. While the Synergem ESRP includes a built-in PRF and basic policy store by default, certain clients prefer to integrate a custom third-party policy engine, and Synergem fully supports that configuration using the Synergem policy distributor. In this diagram, the ASC or SSC are depicted as a single instance handling both ingress and egress, though in some deployments these roles may be implemented as separate functions for scalability or redundancy. So it all begins here at what we are calling step 0, when the SIP invite arrives at the SSC from the Border Control Function, or BCF. From there, the SSC sends a request to the media bridge to open a new conference. That's where we're going to anchor the call. You can think of it as a multimedia conferencing bridge, a place where we temporarily park the call, and then we're going to invite all the other parties, like the next PSAP and the routing path, to join that same conference session. Once the call is anchored, the SSC reaches out to the ESRP to ask for the next routing destination, essentially saying, okay, who's next? Who should we invite to this conference call? But before the ESRP can make that decision, it realizes it still needs location information to determine where the call should go. So it turns to the location information function, or the LIF, with a request that says, hey, I need you to find this caller's location for me. Next, the LIF service sends what's called a held query to a location database or a location information server, often referred to as the LDB or LIS. That LDB or LIS then responds with location data in what's known as a PIDA-flow format, short for Presence Information Data Format dash location object. Now, that location data can come in one of two ways. It might be location by value, which is a detailed civic address, things like street address, city, state, zip code, and in some cases even building or floor information. Or it can be location by reference, which is essentially a secure link that says, click here for the most current location of this caller. That link allows the system to retrieve the latest, most accurate location data in real time. Sometimes this query can also return additional call data. For example, if a call has been transferred from another service, or if extra context is being passed along, such as information about the caller or the originating device. As NextGen 911 continues to evolve, we'll see even more of this enhanced information traveling along with each call. Once that lookup is complete, the LIS sends the location data back to the ESRP, formatted in a standard XML PIDA-flow format, ready to be used for routing and policy decisions. At this point, the ESRP now knows the caller's location, so the next question becomes, which agency should I send this call to next? To find that answer, the ESRP sends an agency query to the lost service. That's the location to service translation function. The lost service then reaches out to both the ECRF and the LVF using the lost protocol to determine which public safety agency is responsible for handling this call. Once that lookup is complete, the ECRF LVF return the appropriate agency information to the lost service, which then passes that data back to the ESRP. Now, the ESRP has everything it needs, the caller's location and the agency destination, so it can move forward with routing the call to the correct next hop in the process. Before the ESRP engages the next agency in the call, it first needs to check the policy rules, just to make sure it knows exactly what to do if that agency isn't able to take the call. So the ESRP sends a query to the policy routing function, or PRF, along with the agency information it just received. The PRF then looks up the relevant Next Generation 911 policy data for that agency, checking the rules that define how calls should be handled in different scenarios. These policies can come from two possible sources: an external policy store, which is optional and often used by clients who manage their own routing logic, or the internal policy store that's built right into the Synergem ESRP. Once the lookup is complete, the NextGen 911 database returns the full list of policy rules for that agency back to the PRF, ready for evaluation and enforcement. Once the policy routing function has identified the proper agency, it sends that agency URL back to the ESRP along with the first applicable policy rule from the list. We'll talk more about policy routing rules and how they're applied in detail during a later session. Now, the ESRP sends a set of routing directives back to the SSC. It's important to remember the ESRP itself doesn't actually manipulate SIP invites. That's the SSC's job. What the ESRP does do is gather all the key information: the caller's location, the agency details, and the applicable policy rules, and then it tells the SSC exactly what needs to be modified before the SIP invite is forwarded. Essentially, the ESRP says, here are the SIP headers and fields that need updating before you send this on to the next destination. The SSC then updates the SIP invite with those changes and routes it to the media bridge, which in turn sends the invite to the next hop, typically the PSAP, or in some cases another EZNet if it's an inter-network transfer. At that point, the media bridge has invited the new participant to join the conference, and just like that, you now have a three-party conference established. The caller, the core services, and the receiving agency, all connected to handle the emergency call seamlessly. And that wraps up our Synergem ESRP Essentials overview. Thank you so much for spending a little time with us today. We hope this session helped you better understand how the ESRP fits into the next generation 911 core services architecture. Before you go, there's a short knowledge check at the end, just a few quick questions to help reinforce what we've covered. And who knows, you might even see some of these pop up again on a future E&P exam if you're working towards that certification. Again, thank you for your time and attention. I'm Tim Kenyon, Vice President of Product Management at Synergem Technologies. Have a great day, and we'll see you in the next session.